A ticker timer is a device used to analyze motion. You look at diagram here. This is a ticker timer that you can find in the lab. Okay. It consists of a vibrating plate and there's a sharp end here. So once you on the ticker timer, the vibrating plate will vibrate and the sharp end will knock on the ticker tape and produce dots. So this one, how it function, we connect it to an alternating current. It cannot function by using direct current. So a ticker timer is an electrical operated device that marks very short intervals of time on a tape in the form of dots. So you can see here. A long tape is attached to a moving object and threaded through a device that places a dot on the tape at regular intervals of time. So the frequency normally is 50 Hz. So once you connect to the alternating power supply, so you can see the vibrating plate vibrates, thus you can see dots produced. Due to the frequency of 50 Hz, it will produce 50 dots on the ticker tape in 1 second. But in our calculation, in order to calculate speed, velocity or acceleration, normally we don't use the dots. We use the term tick. What is the meaning of tick? Here, one tick is defined as the time interval between two adjacent dots. So this one is count at one tick between two dots. Okay, so you look at here, this is one ticker tape. How many ticks consist on this ticker tape? If you just count dot, how many dots we have? 1, 2, 3, 4, 5, 6. There are 6 dots. But between two adjacent dots, we count as one tick. So this is one tick, one tick, one tick, one tick, one tick. So meaning there are 5 ticks altogether. So based on the direction of motion of the ticker tape, the direction is to the right, meaning the first dot on the right will be the first dot. So that's why this one becomes the first tick. And this one is the last tick. Okay. Displacement over 5 ticks period is from the first dot to the final dot. So based on this ticker tape, it consists of 5 ticks. How can we determine the one tick? One tick depends on the frequency. So if we look at the frequency here is 50 Hz, meaning one tick equals to 1 divided by 50 or equals to 0.02 second. Here we have 5 ticks. Thus, the total time taken for this ticker tape equals to 5 ticks, or 5 times 0.02 second, that is equals to 0.10 second. If you calculate for 10 ticks, meaning 10 times 0.02 second, or equals to 0.2 second. So we are going to use tick in order to calculate for distance, displacement, speed, velocity, or acceleration. So based on the ticker tape that we get from the activity when you use a ticker tape and ticker timer, so we can analyze motion based on the dots that produce. So look at the first one, A. Direction of motion is to the left, meaning the first dot produced is the one that at the left side. So this is the first dot produced. So from the first dots, you can look at what happened to the distance between two dots. So the distance between two dots are constants. So this one, we call it constant tick length. So what can we infer from the ticker tape? Or what we can conclude from the ticker tape? Meaning the object is moving with constant or uniform velocity. Now we look at B. Also direction to the left. So this one is the first dot. So from the first dot to the final dot, you can see the distance between two dots increases. So characteristic, tick length increases uniformly. Okay, so inference based on the dots produced on the ticker tapes. So this object is moving with uniform acceleration. Now you look at C. Direction still to the left. So this is the first dot. So you can see distance between two dots decreases. So tick length decreases uniformly. So inference, the object is moving with uniform deceleration. So you just look at the distance between two dots in order to state the type of motion, because the value of time taken between two dots is always constant. Okay, just now we have discussed one tick equals to 0.02 second. No matter how long the distance between two dots, the time taken still the same, 0.02 seconds. That's why when you want to determine what type of motion based on the ticker tape, you just look at the distance between two dots. Okay, here another two example. So we have two ticker tapes here. Both ticker tape consist of 10 ticks. You look at the first one, distance between two dots is shorter. The second one, distance between two dots is longer. So what can you say about the type of motion of the object based on these two ticker tapes? Look at the first one. So distance between two dots shorter, meaning the object is moving with lower speed. And this one shows distance between two dots are constant. Also shows that constant velocity or constant speed. Okay, second one. Distance between two dots longer, meaning higher speed. And then the distance between two dots also constant, meaning constant speed or constant velocity. So from the ticker tape that produced, we can analyze motion. We can determine the value of speed or velocity or acceleration, and also can state the type of motion of the object. Okay, look at how we produce a ticker tape chart. Let's say we have a very long ticker tapes produced from the activity, maybe consists of more than 50 ticks. So actually from the ticker tapes that produce, we can make a tape chart. How to make a tape chart? So what we do, we cut out 6 strips of 10 ticks ticker tapes. You just count from initial point. You can cut exactly on the dots. And then you count 10 ticks, you cut, you get first strip. And then you continue to cut another 10 ticks. Continue until you get 6 strips. Okay, so actually you can cut more than 6, 10 or 15, up to you. But this one I just discussed about 6 strips. Okay, so once you have 6 strips of 10 tick sticker tapes, paste the 6 strips side by side to form a tape chart. It's like a graph. Okay, so you can draw an axis to represent length of ticker tape of distance and then time taken. Then you paste all the ticker tapes, the 6 strips side by side. Okay, so this one we call it tape chart. Actually from the tape chart we also can determine speed, velocity, distance travel, acceleration, okay, based on the tape chart. So for this 10 tick length, the time taken equals to 10 times 0.02. So the time taken is 0.2 second. So meaning the first strip, time taken 0.2, second also 0.2, third also 0.2, fourth 0.2, fifth 0.2, sixth 0.2. Because the time taken for one tick is always constant. Okay, based on the tape chart that produced, we can also analyze type of motion based on the tape chart. We look at the first one. here. Okay, when you cut out the 6 strip and you paste it side by side, you can see all the strip are in same length. So in this kind of motion, all 10 ticks length are of the same length, meaning distance between 2 dots are constant. So this one we call it uniform velocity. When uniform velocity, the object does not accelerate, or we call it zero acceleration. Okay. And then the second one here, you can see the length of the ticker tape increases uniformly. Okay, so the length increases uniformly, showing that distance between 2 dots also increases uniformly. Thus, velocity increases uniformly, so we call it uniform acceleration. And the third one here, you can see the length of strip decreases uniformly, meaning the distance between 2 dots decreases. So velocity decreases, we call it uniform deceleration. So based on the ticker tape or tape chart, we also can determine the type of motion. So in your textbook, there's activity 2.1. You can refer to your textbook. So aim of this activity is to use ticker tape to determine displacement, velocity, and acceleration of trolley. Apparatus needed: ticker timer, trolley, runway, alternating current power supply, retort stand, and wooden block. Material: ticker tape and connecting wires. Instruction: so we set up the apparatus as shown in figure 2.12. Raise one end of runway slightly so that trolley can move slowly down the runway. So here, you can just increase or decrease the height of the trolley. Attach a 100 centimeter of ticker tape to the trolley. Switch on the ticker timer and release the trolley. Observe the ticker tape obtained. From the ticker tape, determine displacement and calculate average velocity of the trolley. Raise the end of the runway further so that trolley moves with higher velocity down the runway. Repeat step 2 and 3, then calculate acceleration of the trolley. Rearrange the apparatus shown in figure 2.13. So we have next one. Push the trolley from the bottom of the runway and allow it to move up, reverse direction. Stop the trolley when it starts to descend the runway. From the ticker tape obtained, determine deceleration of the trolley. Discuss pattern of motion obtained on the ticker tape. So the first activity, we want to observe what happened when we increase height. So you can see the trolley move down at higher velocity. So we can determine the velocity, average velocity or acceleration. And then we move it reverse direction, so the trolley will decelerate. So from the ticker tape that produced, we will calculate the velocity or acceleration of the trolley. So look at some sample of calculation problem. So let's say we have this ticker tape. Okay, so this ticker tape consists of how many ticks? 1, 2, 3, 4, 5, 6. 6 ticks. Direction is to the right, meaning this one is the first dot. It's very important to detect which one is the first dot and final dot, because you are going to calculate initial velocity and final velocity in order to calculate acceleration. So remember the formula for acceleration: A equals to final velocity minus initial velocity divided by time taken for change in velocity. So look at this situation. The ticker tape figure above was produced by a toy car moving down a tilted runway. If a ticker tape timer produced 50 dots per second, find acceleration of the toy car. So the word 50 dots per second means 1 tick equals to 0.02. Okay, look at the answer here. Number of ticks n equals to 6. Initial velocity, where we should calculate initial velocity. So this is the first tick. So you calculate here, not here. So based on the direction to the right, this is the first dot, meaning this one is the first tick. This one is the final tick. Okay, so initial velocity u, 3 divided by 1 tick. 0.02 second. So we get 150 centimeter per second. Final velocity 0.5 divided by 0.002 seconds, so we have 25 centimeter per second. Thus use the formula of acceleration. The time taken is time taken for change in velocity. In order to calculate time taken for change in velocity, number of ticks minus 1, you need to minus 1, multiply t, or time for one tick. Okay, so based on this, you can see A equals to 25 minus 150 divided by 6 minus 1. So you always minus 1 for acceleration. So 6 minus 1 times 0.02. So you get negative 1250 centimeter second negative 2. So the unit here should be negative 2 here. So this one is for one ticker tape, 6 strip of ticker tape. Let's say we have a tape chart. So this tape chart consists of 5 strips. One strip consists of 5 ticks. So meaning time taken for one strip is 5 times 0.02. That is 0.1 second. So one strip, 0.1 second. So the first strip, okay, here the length is 5 cm. Now we want to calculate initial velocity. So initial velocity you calculate from the first strip. The final velocity is the last strip. Okay, so number of ticks n equals to 5. Okay, for each of the strip, number of ticks is 5. So the time taken 0.1 second. So initial velocity u equals to length 5, read from here, divide by time taken for one tick, one strip, 0.1. So you have 50 centimeter per second. Final velocity, the last strip, the length is 1 cm. So 1 divided by 0.1 equals 10 centimeter per second. So acceleration equals to v minus u divided by t. So the time taken for the tape chart is number of strip minus 1 multiply time for one strip. Okay, so here we have 5 strips. So 5 minus 1 times 0.1. So you substitute the value of v and u. Thus we get negative 100 centimeter second to negative 2. So this one we get negative value, meaning the trolley is moving with deceleration down the slope. Okay, so this is how we calculate for the ticker tape that produced from the activity.